1 students, so your final exams are approaching and many of your exams have already started. So yes, to help you with your preparation, to boost up your preparation, today I am here to discuss the most important questions from all the chapters of chemistry. Okay, so I've taken almost 5 to 6 questions from all the chapters and you need to at least do these many chapters and go to your exam. Okay, these are the most repeated, most important, most expected questions. So overall you can say it as a passing package. Okay, so I can say that if you do this 40 to 50 questions that I have in this video, then definitely you will get pass marks. You can even get better marks if you do all the questions perfectly. Okay, so yes, now let us start with the first question, the first chapter, some basic concepts of chemistry. Okay, so this first question is based on, like, it is a must question. You can easily expect this question, that is from your empirical formula and molecular formula concept. Okay, so the question says that a compound contains 4.07 hydrogen, 24.27 carbon and 71.65% of chlorine. Its molar mass is 98.96, sorry, not percentage, 98.96 gram per mole. Find its empirical formula and molecular formula. So every exam you will have one question from molecular formula and empirical formula from the first chapter, so definitely you should not miss this question. Okay, so now if I tell you how to do this question, so first you have to make a table, right? So where we have mentioned all the elements. So you have what? Carbon, hydrogen is there, carbon is there and chlorine is there. Sorry, not oxygen, it is chlorine. Okay, now mention the percentage. So hydrogen is 4.07, okay, carbon is 24.27, okay, chlorine is almost 71.65. okay, now here I'll write the molar masses. Carbon molar mass is 12, hydrogen is 1, chlorine is 35.5. okay, now if I just calculate the number of moles, you have to divide this by this. 24.27 divided by 12 will be almost equal to 2. 12 2s are 24. 4 divided by 1 will be 4. Okay, now 35 into 2 is 71, right? So it will be almost equal to 2. Now if I take whole number ratio, I'll get 1, 2 and 1, right? So what is the empirical formula I will get? Empirical formula is equal to CH2Cl. Now what is my empirical formula mass? You have to calculate empirical formula mass. Okay, so what I have done here, basically let me just tell you the steps properly. First, here you have to write the percentage, here you have to write the mass. Okay, you have to divide this percentage by mass, so that will give you number of moles. Okay, once you have got the number of moles, this one is your simplest whole number ratio. Okay, so this is your empirical formula. Now how to calculate empirical formula mass? Just you have to add the masses of this one. So carbon is 12, okay, 2 hydrogens are there, chlorine is 35.5. okay, so 35, 36, 37, 37 plus 1 means 10, that is almost 47, 48, 49. okay, so that means I can say 49.5 is the empirical formula mass. Next, what is the N value? You have to calculate. N value is what? Molecular mass. Okay, molecular mass divided by empirical formula mass. So that is your 98.96, okay, divided by 49.5. okay, so I can say this is almost equal to 2. okay, it is equal to 2. 49 2s is 98. Now if I want to calculate the molecular formula, okay, so what is molecular formula? It is empirical formula into the N factor. What is my empirical formula? CH2Cl into 2. So that will be equal to how much? I can write it like C2H4 and Cl2. Okay, so my answer is this one, C2H4 and Cl2. Clear? Now let us see the next question here. Okay, there was a second part of this question as well. What is limiting reagent? Okay, so limiting reagent, all of you know, is that reagent which is present in less amount and is consumed completely in the reaction. You can also write that limiting reagent, it determines the amount of product formed. Clear? This is the limiting reagent. Now let's see the second question. State Gay-Lussac's law of combining volume. This is very important question. So just we'll see the statement. This law states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases at same temperature and pressure. Okay, now you should learn this definition. Apart from that, you should also learn the definition of law of conservation of mass. Okay, law of conservation of mass, then law of definite proportion, okay, then law of multiple proportion, then Avogadro's law and Gay-Lussac's law. Okay, so all the four laws, their statements, you should remember. Any one statement can be asked. Now coming to the next question, if 120 gram of propane is burnt in excess of oxygen, how many grams of water are formed? So if I just draw, this is stoichiometry based question. So if you have propane, right, so that is C3H8 plus O2 will give me CO2 plus H2O, right? So now if I want to balance this one, it will become 3 CO2. Okay, so now 8 hydrogen are there, so 4 into H2, that is 8. So 3 2s are 6 plus 4 10 oxygen, so I have 5 O2, right? So it is saying how many gram of water will be formed. So now see, the reactants are two reactants, right? One is propane and one is oxygen. The question is, there is nothing mentioned about oxygen, only one reactant is given here. So we can put a direct relation between the C3H8 and 4H2. So I can say that 1 mole, what is the mass of this 1 mole of C3H8? 12 3s are 36, right? 36 plus 8 is 44 grams, right? So I can say here, see, C3H8, right? 12 3s are 36 plus 8, 44. Yes. So I can say that 44 gram of, see, 44 gram of C3H8 means that is equal to 1 mole. Okay, produces how much gram of water? 4 molecules of water. That means 1 mole is 18, 4 into 18, right? So I can write 4 into 18, or you can just calculate like 72, right? 72 gram of water. Okay, or you can say 4 moles of water. Now we have 1 gram of C3H8. How much will this one will produce? 72 by 44 grams. Now in the question you have been given with 120 grams. Okay, so how much will that will be? 72 by 44 into 120. So 4 11s are 4 30s are. Okay, so now if I solve this, 72 into 30 into 11, so it will be like 3 2s are 6, 3 7s are 21, 2160 by 11. So I can divide it by 1 11 1s are 11, then I'll get 10 back, 106. So 11 9 I'll take, right, 99. So 19. So the answer I'll be getting here is around 196.36 gram. Okay, that calculation you have to do. Next, question number 4, calculate the mole fraction of ethanol in a solution containing 20 gram of ethanol and 100 gram of water. Very simple question, direct mole fraction based question. Okay, so okay, now coming to this one, that is you have calculated the mole fraction. So what's the formula of mole fraction? Mole fraction of any component is equal to number of moles of that component divided by the total components. Right, now if I see first what I have, ethanol. What is the mass of ethanol? What is the mass of ethanol? So it is 12 3s are 36, 36 plus 6 is 42, 42 plus 16, that is 52, 52 plus 6 is 58. Okay, I think I have calculated the mass correctly. C2H6O, right? So 12 2s are 24, then I have 6 and then I have 16. So yes, 2 3 4. 1 second, I did wrong calculation. 6 12, yeah, 12 2s are 24 plus 6 plus 16. Okay, 6 plus 10 plus 6 16, 2 3 4. Yes, I did a wrong calculation here. So yes, I am very poor at calculation, students, so please forgive me. Mass of this one is 46. Okay, yes. Now coming to this is the mass, this is the molar mass of ethanol, okay, capital M for molar mass. Then how much? 20 gram of ethanol is there. What is the mass of ethanol? 20 grams. So that is okay. Now I'll calculate the number of moles of ethanol, that is given mass by molar mass, so 20 by 46. Now if I want to calculate similarly the mass of water, right, mass of water is how much? 100 gram. Okay, what is the molar mass of water? It is 18 grams. So what is the number of moles of water? 100 by 18. Okay, now if I want to calculate the mole fraction of this one, so what it will be? So you want to calculate the mole fraction of ethanol, right? So if I just substitute this one correctly, then I will get mole fraction of ethanol is equal to number of moles of ethanol by number of moles of ethanol plus number of moles of water. So that will give me 20 by 46, okay, whole divided by 20 by 46 plus this one is 100 by 18. Okay, so if I solve this, I will be getting around 0.077. Very easy question. Next question is, how are 2 mole NaOH and 2 molar NaOH different? Okay, this is very important question, and I'll say very tricky concept based question. So how are 2 moles of NaOH and 2 molar NaOH different? Now see, when you say 2 moles of NaOH, okay, that means 2 into Avogadro number of NaOH molecules. Okay, when I say 2 molar, okay, that implies 2 moles of NaOH in 1 liter of solution. Okay, that is what molar and mole means. Next, an organic compound contains 69% carbon and 4.8% of hydrogen and rest being oxygen. Calculate the masses of carbon dioxide and water produced when 0.2 gram of this substance is subjected to complete combustion. Okay, this is also important question. So now see, first of all, we have 69% of carbon and 4.8% of hydrogen and rest is oxygen. So what is the percentage of oxygen? Let us first calculate. Percentage of carbon is how much? 69%. Percentage of hydrogen is 4.8%, right? Then what will be the percentage of oxygen? So if I add 69 plus 4, that is equal to 73.8. So that is 100 minus 73.8. So that will give me 10 minus 8 2, 9 minus 3 6, 9 minus 7 2. 26.2% is oxygen, right? Now what this is of what? This is of the organic compound 0.2. That means how much mass of carbon is how much? Mass of carbon is 69%, okay, of what? Of 0.2 gram. So how much will that come? 2 9s are 18, okay, 2 6 are 12 plus 1 13. Then I have 0.1 here, so 0.138 gram. Okay, so out of 0.2 gram, 0.138 gram is your mass of carbon. Okay, sorry, 1 second. Yes, 0.138 gram is mass of carbon. Next, what is mass of hydrogen? Mass of hydrogen is 4.8% of 0.2, right? 4.8% of 0.2. So it is 2 8s are 16. 2 4s are 8 plus 1 9. Then I have 2 decimal again, then so it is 0.0096 grams. So you can see how less is the composition or the mass of hydrogen. Next we have what? Oxygen is 26.2%, right? So what is the mass of oxygen? 26.2% of 0.2 grams, right? So what, how much I'll get? 2 2s are 4, 2 6s are 12, 2 2s are 4 plus 1 5. So I have 2 decimals and then I'll put 0.0524 grams. Okay, so these are the masses of the compound I got. So if I just add them all, I should get 0.2 grams, right? So let us just check 0.138 and then I have 0.0096 and then I have 0.524. So 6 plus 4 10, 9 plus 1 10, 18 19 20, 5, 6, 7, 3, 10. So I am getting 0.2 mass, right? So I have got the correct calculation here. Okay. So this is what I got in that particular organic compound. How much carbon is present? Carbon is this much. How much hydrogen is present and how much oxygen is present? Now the question is asked to you, what calculate the masses of carbon dioxide and water produced when 0.25 gram, 0.2 gram of this substance is combusted. Okay. So now you see here how to do. You have to calculate the mass of carbon dioxide that will be produced, right? So if you see in carbon dioxide, okay, in this 1 mole of carbon dioxide we have 12 grams of carbon, right? 12 grams of carbon is there. So I can say that like this, how to put this, I can say like from 12 gram of carbon I will get 44 gram of carbon dioxide. Okay, if 12 gram of carbon is there, then 44 gram of carbon dioxide can be there. Now similarly, if I have 1 gram of carbon, then I will have 44 by 12 gram of carbon dioxide. So if I see from 1 gram of C, we have this much 44 by 12 gram of carbon dioxide, right? Now we have how much gram of carbon? We have 0.138 gram of carbon. 1 second. Yes. So I have 0.138 gram of carbon. So that will be what? 44 by 12 into 0.138. So if you solve this, how much we will get? So I can write 4 3s are 4 11s are, okay. Then I think 8, this is also divisible by 3. So I can just make it like 3 4s are 3 46 are, so 0.046. So 11 into 0.046, how much will get? 11 6 are 66, 11 4s are 44, 44 plus 6 is 50. So I'll get 0.506. So mass of carbon dioxide produced is 0.506. Okay, let me write it clearly. So that is 0.506. Okay. Now similarly, can we do calculation for oxygen as well? So like water. So now you see, if you have water, okay, so what is it? Like I can say that from 2 gram of H, I can get 18 gram of water, right? So from 1 gram, how much I will get? 18 by 2. Okay. Next, how much this one was there? 1 second. Hydrogen was 0.0096, right? So 0.0096. Let me write down again, H2O, right? So from 2 gram of hydrogen, I have 18 gram of water. Now from 1 gram of hydrogen, I have 18 by 2 gram of water. Now 0.0096, it is 18 by 2 into 0.0096. Okay. So now if I solve this, how much I'll get? Okay. 9 6 are 54, 9 9s are 81, 81 plus 5 86, 8.0864 grams. Okay, 0.0864 gram. So what is the mass of water that is produced? 0.0864 grams. So this is the answer. Next, give an example of element and compound. So element example you can write down sodium, compound example you can write down CO2. Okay, H2O, CO2, anything. Fine. Now we'll go to the next chapter, that is structure of atom, and let us see some important questions from here. Mention 2 limitations of Bohr's model. Very simple question. State Heisenberg uncertainty principle and write its mathematical form. What is the maximum number of electrons in the shell with principal quantum number n? Okay, very direct and theoretical questions. So limitations of Bohr's model you should be able to know. Does not explain the spectra of atoms having more than 1 electron. Okay, it is only explaining you the spectra of hydrogen atom, okay, not atoms which is having more than 1 electron. Next, does not explain the splitting effect in the magnetic field, that is your Zeeman effect, and the electric field, that is Stark effect. These are the limitations of Bohr's model. Next, what was the question? One second. State Heisenberg uncertainty principle. Okay, so we have 3, this one B. So what is Heisenberg uncertainty principle? It states that we cannot calculate the momentum and the position of a microparticle simultaneously. Okay, so that is what, and what is the expression? Delta x by into delta p is equal to greater than or equal to h by 4 pi, and here you have to mention the terms. Delta x is uncertainty in position, delta px is uncertainty in the momentum of the particle. Next, how many electrons can be hold? It is 2n square, where n is what? N is the number of the shell. Okay, n is the shell number. Clear? Next, question number 2, explain the significance of quantum number n, l and m. This is very important question. Every year we get a question from here. Calculate the wave number of a yellow radiation having wavelength 58,000 into 10 to the power of minus 10 meter. So I'll just first do the B part. Okay, how to calculate wave number? Wave number is nothing but 1 by wavelength. So 1 by 58,000 into 10 to the power of minus 10. So if I solve this, you will get the answer for this one. Now let us see what is the significance of quantum numbers. So you can see here, principal quantum number. What does it tell? It defines the shell. It determines the size of this orbital. As the n value can change from 1 to 3 increases, size and energy of the orbital also increases. So basically the principal quantum number tells you about the size and the energy of the orbital. Okay. Next, azimuthal quantum number, it defines the shape of the orbital, and it is also, its value changes from 0 to n minus 1. Now coming to magnetic quantum number, it tells you about the spatial orientation and of the orbital and the number of orbitals present. Okay. Now spin quantum number, it refers to the spin of the electron. Now if you have this question, the answer will be 1.72 into 10 to the power of 6 meter inverse. Okay. Next, for the element with atomic number 24, write the electronic configuration, write the value of n and l for its electron in the valence shell, how many unpaired electrons are present in it, state Pauli's exclusion principle, is it possible to have the configuration 1s3? Very simple question. 24 atomic number, what will be the configuration? Okay, so if I have this one, A, right? A, first I will write the configuration, that is 24, 1s2, 2s2, 2p, 6, 3s2, 3p. Now 6, 7, 8, 9, 10, 11, 12, 3s6, 4s2, I think 4p, 4. I think this is done. 6, 7, 8, 9, 10, 11, 12 plus 6, 18, 19, 20, 24. Next, what is the value of n and l for its electron in the valence shell? Okay, the value of n and l. So you know n value is 4. Okay, n and l for its electron in the valence shell. So what is the l value? The last electron is in the p value, l value is 1 for that, right? How many unpaired electrons are present in it? So if you see 4p4, we have 3 orbitals here. So 1, 2, 3 and 4. So how many unpaired electrons are present here? 2 unpaired electrons. Now what does Pauli's exclusion principle says? No 2 electrons can have same value for all the 4 quantum numbers. Okay, that you have to represent. Okay, so you can see, 1 second, 6, 7, 8, 9, 10, 16, 17, 18. Okay, here a small mistake. I forgot. Yes, sorry. Here I have missed 3D, right? Sorry. This is a small mistake here. First, after 3p, what happens? 3D comes, right? So first 3D will be filled and then 4s will be filled. So how much we will get? 6, 7, 8, 9, 10, 11, 12 plus 5, 17. 3D 5 and 4s 1 will get, right? Okay, I think yes. So what is your n value? Last n value is 4, s value will be l value will be 0. Okay, I forgot about that. Next, how many unpaired electrons are there? 6 unpaired electrons will be there. Let us see the next question here. For the element with atomic number 24, write the electronic configuration. Very simple, just you have to write the electronic configuration. 1s2, 2s2, 2p6, right? 3s2, 3p6. Okay, now after 3p6 we have 3d 5 and then we have 4s1. Okay, so this is the configuration for 24. You know, chromium has a very special configuration. So what is the value of N and L? So N value is for that is your last valence shell, right? So N value is 4, L value is, S value is 0, so L value is 0. How many unpaired electrons are there? Here we have 5 unpaired electron, here we have 1 unpaired electron, so number of unpaired electrons are 6. Clear? Next, Pauli's principle you can state. So you can see Pauli's principle states that in an atom no 2 electrons can have all the 4 set of quantum numbers same. Okay, let's move to the next question. What is Auber principle? And given the difference between orbit and orbital, write an expression to calculate the radius of the stationary state for electrons of hydrogen. So what does Auber principle says? That electrons should be filled in the energy level, like lower energy should be filled first and then the higher energy, right? So the electrons enter into the different atomic orbitals in the increasing order of their energy. That is your Auber principle. Now what is the difference between orbit and orbital? We'll discuss that. Before that, we'll do this question. What is the expression? R is equal to n square a naught by z, right? So R is equal to a naught into n square by z, where n is the orbit, z is the atomic number. Okay. Next, orbit and orbital, many differences are there. You can just remember any 2 points. So it is a circular path, it is a space, it is where the electrons revolve around the nucleus. It represents a space where the electrons can be present beside an atom or inside an atom. Next, these are non-directional, these are directional except the s orbital. Other points also you can remember, but any 2 is fine. Next, we will move to the 5th question. Sketch the shape of px and dz square orbital. Identify the property exhibited by these two compounds. Write the orbital box type electronic configuration of p4 and d4 configuration to Hund's rule of maximum multiplicity. Okay, so if I see the shapes of px orbital, you can just draw like this, right? This is, if this is x, so this is my px orbital. How will be dz square? Okay, so if you remember, this is your dz square orbital, right? So this is first part, A. Next, what are these two? 40, the mass numbers are same, right? So what do they belong? They are isobars. Okay. Next, P4 and D4 electronic configuration. C is P4. Okay, so we have here 1, 2, 3, 4, and then I want D4. 1, 2, 3, 4, 5. 1, 2, 3 and 4. Okay, so first you should fill 1 electrons, then pairing of electrons takes place. Okay, now we'll go to the 3rd chapter, classification of elements and periodicity in properties. What is ionization enthalpy? How does it vary across a period and down the group? So all of you know it is the energy required. So it is the amount of energy required to remove an electron from the isolated gaseous atom in the ground state. Okay, along the period it increases and down the group it decreases. Okay, this is very, very famous question. Next, nitrogen has higher ionization and enthalpy than oxygen. Give reason. That is because of nitrogen has half filled electronic configuration, right? Nitrogen has more stable half filled electronic configuration of P3, but oxygen has P4 configuration. Okay. Next, arrange the following in the decreasing order of their ionic radius. Okay, state the modern periodic law and assign the IUPAC name of the element with atomic number 114. Okay, so first of all, if you see the ionic radius, more is the negative charge, more is the radius, right? So here 3 minus is there, O2 minus is there. So what is for the I can say the largest one will be this one, then O2 minus. When it becomes positive, it becomes small. So we have Na plus and then Mg2 plus. Okay, more negative, more bigger size, more positive, less size. Okay, so more positive is less size, more negative will be bigger size. What does modern periodic law says? It says that the properties of the atoms are the periodic functions of their atomic number, not atomic masses. Next, what is there? you have this 114, right? So how do we name it? IUPAC name, all of you know this. So yes, let's see. This is the order first, okay. The physical and chemical properties depend on the periodic function of the atomic numbers, okay. Next, for one we have to use un, right? For another one, another un, then for 4 it is quad, and the ending should be IUM. So un quad em, clear? Next, question number 4. What is the basic difference or in approach between the Mendeleev's and modern periodic table? Mendeleev says that the properties are the periodic function of the atomic masses, whereas modern periodic table says that they are the periodic functions of the atomic numbers. What are isoelectronic species? Species with same number of electrons. Okay, very simple question. You can read here. The species which have the same number of electrons are called as isoelectronic species. Okay, very easy and direct question. Next, why beryllium exhibit anomalous behavior from the rest of the elements in the group? Now this question can be for any element of the first period, okay. So any element, for the first element of any group, this question is applicable, okay. It can be either beryllium, it can be even like for example nitrogen, oxygen, fluorine, okay, all the carbon, all the first members of any group have this anomalous property. What is the reason for that? It is because of their small size, okay, relatively high electronegativity, small size, high electronegativity, and ionization energy, okay, high ionization energy as compared to other members, okay. Next, C is what? Absence of d orbital, okay. So 3 points are there: small size, high electronegativity and high ionization enthalpy, and third one is absence of d orbital. Clear? Okay, now if we move to the 4th chapter, that is chemical bonding and molecular structure, I have some important questions here. So first one is to write the electronic configuration of hydrogen molecule and calculate the bond order in H2 molecule. So this is very repetitive question, and why helium molecule does not exist. So if you know H2 molecule, one hydrogen has 1 electron, 2 hydrogen will have 2 electron. I can write sigma 1 is 2. That is the configuration. One, what is the bond order? Bond order is what? Number of bonding minus anti-bonding. There is no anti-bonding, so bonding minus anti-bonding divided by 2. So that is 1. Clear? Now why helium molecule does not exist? So if you see, helium has 4He2, right? So helium has 2 electrons, another helium will have 2 electrons, so total 4 electrons. So if I write sigma 1 is 2, sigma star 1 is 2. So what is the bond order? Bonding is 2, anti-bonding is 2 divided by 2. So that gives you 0. So since the bond order is 0, the molecule does not exist. You can see the answers how you have to write down. Clear? Next, mention 2 conditions for the linear combination of atomic orbitals. Draw the shapes of bonding molecular orbital and anti-bonding molecular orbital formed by the combination of 1s and 1s atomic orbitals. Very easy question. First of all, what are the conditions? Conditions is they must have same or nearly same energy, okay, first condition, and then they must have the same symmetry about the nuclear axis, okay. That is the first thing. Now if you see bonding, what will happen? Same configuration, same constructive overlapping will be there. You will get bonding orbital like this, and if there is anti-bonding orbital, it is formed in this way, okay. So this is the diagram you can draw like this. Next, what is sigma and pi bond? Why is sigma bond stronger than pi bond? This is also one of the most repeated questions. So sigma bond is formed by head-on overlapping, right? Head-on or axial or end-to-end overlapping of bonding orbitals along the internuclear axis, whereas pi bond is formed by the parallel lateral overlapping of the bonding orbitals perpendicular to the internuclear axis. So what happens? See, this is your internuclear axis, okay. I'll draw first internuclear axis. 1 second. See, suppose this is your axis, internuclear axis. So first overlapping takes place like this. This is sigma overlapping, and if you have pi bonding, it is overlapping like this, perpendicular. The overlapping is perpendicular to the internuclear axis, okay. Why sigma bond stronger? Because in case of sigma bond, the extent of overlapping is much more, okay, because they are head-on overlapping, so the extent of overlapping is very high, okay. Now if we have question number 4, explain sp hybridization by taking BeCl2 as an example, okay. So how will you write? See, first of all, in BeCl2 sp hybridization is there. So you can say that one s and one p orbital of almost equal energies undergo hybridization to give you sp hybridization. Okay, so now how will it forms? So this is the diagram. See, first beryllium electronic configuration is 1s2 2s2, then it undergoes excitation where one of the electron is excited to 2p. Then what happens? Be and sp hybridized state, these two undergo hybridization. Okay, and we have two hybrid orbitals, two atomic orbitals combined to give you two hybrid orbitals, sp and sp. Okay, now what will happen? This chlorine and this chlorine will overlap with this one, and we will get this one as the final structure. Okay. Next we have difference between bonding and molecular anti-bonding orbital, and calculate the bond order of hydrogen molecule. This question I have already done. And if you see bonding and anti-bonding, it is formed by the addition of atomic orbitals, it is formed by the subtraction or the overlap of the atomic orbitals. Then you can write down the wave function is psi a plus psi b, here it is psi a minus psi b. Here you can write energy is lower, energy is higher. Okay, bond order of hydrogen we have already calculated. Next, calculate the formal charge on each of the oxygen of the ozone molecule. So if I draw ozone molecule, the structure is like this, right? We have 6 here, we have 2 here, and we have 1 here. Right? That is the structure of ozone. So let me just number it 1, 2, and 3. What is the formula? Total valence electron, okay, minus non-bonding electrons minus bonding electrons by 2. Okay, that is there. Now if I calculate for O1, okay, so this one, so total valence electron is always 6. Okay, here I have 2 lone pairs, no 3 lone pairs, yes. Okay, next non-bonding electrons is also 6, so there is one bond, so bonding electron is 2, so 2 by 2, so that will give me minus 1. So what is the formal charge on this oxygen? It is minus 1. Now coming to O2, O2 is having bonding valence electron is 6. How many non-bonding electrons are there? 2. Minus bonding electrons are 1, 2, 3. 6 by 2. Right? So this will give me plus 1. Right? So this is plus 1. Now if I calculate for O3, you have bonding electron, valence electron is 6, non-bonding electrons is 4, bonding electrons is 4 by 2. Okay, so that will give you 0. Okay, that is how you can calculate the formal charges. Now let us move to the next question, that is your thermodynamics question. What is spontaneity? And mention entropy and free energy criteria for spontaneous process. Okay, here's something got. Okay, so what is spontaneity? When a reaction can occur by itself without any initiation, that is called spontaneity. And entropy, mention entropy and free energy criteria for spontaneous process. So entropy should always be positive and free energy should always be negative. Now give the relationship between delta H and delta U for the change, okay, among the internal energy and work, which one is a path function. So work is a path function. Okay, so you can see the answers here. A process which occurs on its own with or without proper initiation under given set of conditions is called a spontaneous process. Entropy has to be positive, free energy has to be negative. Now for this particular question, if you know delta H is equal to delta U plus delta NG RT, right? So what I can put? Delta U plus, what is delta NG? 2 minus 0, 1 minus 0, 1, so that is RT. Okay, delta U plus RT. Now path function is a work function. Okay, next we have the enthalpy of combustion of methane, graphite and dihydrogen. Okay, enthalpy of combustion of methane. So if I have like this, okay, just let me write down this one, and if I want to balance the reaction, it has to be 2O2. Okay, how much energy is given here? Minus 890. Okay, next I have enthalpy of combustion of graphite. Okay, what is the energy required or released here? Minus 393.5. Okay, next dihydrogen. Okay, so this is dihydrogen. Okay, so to balance it, I have half O2. Okay, what is delta H here? So let me just write down the value because I have less space, students. So that is 285.8. Okay. Okay, the enthalpy of combustions have been given. Then calculate the enthalpy of formation of methane. So how will the methane form? See, methane formation reaction means you have to form 1 mole of methane using C plus 2H2. Right, this is the, we have to calculate the enthalpy for this reaction. So okay, we have the first reaction, I have methane. So I will take this first reaction and I will reverse it. Okay, so if I just take this reaction and reverse it, I'll get CO2 plus H2O, okay, gives CO2 plus 2H2O gives CH4 plus 2O2. And what is the value here? Plus 890. Okay. So I got methane on the right side. Next I want carbon. So this equation can give me carbon. So I will add this one. Carbon plus O2 gives CO2 and this value is minus 393.5. Okay. Next I want is 2H2. So I have to multiply this equation with 2, right, because I want 2H2. So I will get here 2H2. Okay. If I multiply here 2, this will become O2, gives me 2H2O. Okay, and the value here is minus 285.8 into 2. So that is 2 8s are 16, 2 5s are 10 plus 1 11, 2 8s are 16 plus 1 17, 2 2s are 4 plus 1 5. So minus 571.6. Okay, now let us add these all reactions, how much I will get. So what all things I can cancel? Let me use a different ink here. So you can see CO2, CO2, 2H2O, 2H2O. Then I have O2, O2, 2O2, this side also 2O2. So I am left with C plus 2H2 plus CH4. That was the required equation I wanted, right? Okay, so now if I just solve this, how much I'll get? So let me just add first this one, 393.5. Okay, and I have 571.6. Okay, so I will add this, I will get 965.1. So 890, so I have 890, okay, minus 965.1. Okay, so you can solve this and the answer you will get will be the answer for this question. Okay, so that was hurt. Then next question was, what is enthalpy of combustion, right? So enthalpy of combustion represented by this one, it is the energy released from combustion of 1 mole of a substance. Okay, done. Next we have what is intensive property of a system. Pick out the intensive property. So intensive properties are those properties which does not depend on the amount of substance, right? It depends on the like intrinsic property doesn't depend on the amount of substance. So here the intensive property is obviously density. Okay, then only density. Next, 2 mole of an ideal gas undergoes a reversible isothermal expansion from volume 2.5 liter to 10 liter. Calculate the work done by the gas. So we know what is the formula for work done, minus 2.303 nRT log of V2 by V1. Let me substitute here, minus 2.303. What is N value? 2 moles. R value 8.314. Temperature value 27 degrees Celsius. I think 27 means 27 plus 2, 73, and that is your 300 Kelvin into log of. What is V2 minus V1? 2.5 to 10 liter, right? So 10 by 2.5, or you can write 100 by 25. Okay, 100 by 25, and that will give me log of 4. Okay, log of 4 means that is again 2 log 2, right? So minus 2.303 into 2 into 8.314 into 300 into this 4 can be written as 2 square, that can be written as 2 log 2, right? And what is log 2 value? 0.301. So just multiply all this and you will get your answer. Okay, so that is very simple question. Next, state Hess's law of constant heat of summation. Write Gibbs equation. Using delta G, how do you decide whether a reaction at a given temperature is spontaneous or non-spontaneous? So Hess's law, what does it say? If a reaction occurs in multiple steps, okay, the final enthalpy of reaction is the addition of the enthalpies of intermediate steps, right? Like for example, if a reaction is from A to B, okay, then B to C, then C to D, and we have our A to D reaction directly. So A to D reaction enthalpy will be equal to this plus this plus this. Okay. Now Gibbs energy equation is what? Delta G is equal to delta H minus T delta S. How will you tell if delta G is negative, reaction is spontaneous, right? Very simple question this one. Yes, Hess's law states that the enthalpy of change is same whether a reaction is carried out in one or more several steps. Okay. Now delta G is equal to delta H minus T delta S. Delta G negative means the reaction is spontaneous. Okay. Next, what is standard enthalpy of vaporization? Write the thermochemical equation for vaporization of ethanol. Calculate the enthalpy of vaporization of ethanol given enthalpies of formation of liquid ethanol and gaseous ethanol are this much. Name the apparatus used to calculate the combustion reactions at constant volume. Okay. So enthalpy of vaporization means what? Amount of heat required to vaporize 1 mole of a liquid at constant temperature. Okay, you have taken 1 mole of a liquid at one constant temperature. If you are vaporizing it, how much energy you need to give to the system, that is called as your enthalpy of vaporization. Now what is the equation for enthalpy of vaporization of ethanol? So liquid ethanol to gaseous ethanol, that is your enthalpy of vaporization. Now you have to calculate this reaction enthalpy. So products minus reactant, gaseous enthalpy was given to you minus 235, right? How much it is? Minus 235.4. and liquid is minus 277.6. okay, so if you solve this, you will be getting plus 42.2. Now what was the device name? Device name is bomb calorimeter. Okay, let us move to the next chapter, that is your equilibrium. Okay, so equilibrium will solve certain questions. So the first one is chemical equilibrium is dynamic in nature, explain. Now discuss the effects of temperature, that is Lee-Chatterley principle, on this reaction. Give the relationship between Kp and Kc. So why does chemical equilibrium is dynamic in nature? So it is dynamic because the reaction does not stop in an equilibrium. The reaction takes place, but the rate of forward reaction and the rate of backward reaction is equal. So that is why we visualize that the amount of reactants and products are constant, but actually they are not constant. The reaction proceeds there, right? So that is why they are called dynamic equilibrium. Next, what is the effect of temperature on the basis of Lee-Chatterley principle? So you can see this is an exothermic reaction. So if you decrease the temperature, reaction will go in forward direction. Now what is the relation between Kp and Kc? Kp and Kc is equal to RT to the power of delta N. Okay. So there is no change in the concentration of the reactants and products in the reaction mixture, and the reaction continues in both forward and backward direction with the same rate. Okay. So when the temperature is increased according to the Lee-Chatterley principle, to oppose the increase in temperature, the decomposition is favored and the equilibrium is favored or shifted towards the left. Okay. Next, Kp is equal to Kc to the power of RT into to the power of delta Ng. Next, show that pH plus pOH is equal to 14. So this we can do very easily like this. So we know that what is it? Yeah, ionic product of water, right? H plus plus OH minus is equal to 10 to the power of minus 14. Now if I take log on both sides, so I'll get log of H plus, okay, plus log of OH minus, okay, is equal to minus 14. Now if I take negative on this side, okay, so minus log of H plus, okay, then minus log of OH minus is equal to 14, right? So what is minus log of H plus? Nothing but pH. Minus log of OH is nothing but pOH is equal to 14. That is how it is proved. What is buffer solution? Any solution that can resist the change in pH. Example of acidic buffer. So if you want an acidic buffer, so you have to take a weak acid and a salt of weak acid. So I can take like CH3COOH and a salt of weak acid, that is CH3COONA. Okay, these two mixture will give me an acidic buffer. Relation between solubility and solubility product of BaSO4. So that is your KSP. So I will show you the answer here. So first part, this is I have explained, this also I have explained. Now what is BaSO4? See, if you have BaSO4, how will it dissolve? Ba2 plus SO4 2 minus. Okay, so what will be equal to KSP? That is equal to S square. Yeah, so that is the formula. Next, we have defined the acid and base by Bronsted-Lowry concept. Identify the conjugate acid base pair in the following reaction. So Bronsted acid and base is like what? See, Bronsted acid means something which can donate H plus, and Bronsted base is something which can accept H plus, right? Conjugate acid and base pair always differs by one hydrogen, right? So here this is one conjugate base pair and this is another conjugate base pair. They should have a difference of one proton. Now what happens to the pH of water when NH4Cl solid is dissolved in it, and why? Okay, so if you see you have water has the ion H plus and OH minus. Now when you dissolve this one, what you will get? NH4 plus, okay, and Cl minus. Now this one will form a base, weak base, which will not dissociate, right? Weak base will have very partial dissociation, but these two cannot even though they form a bond, but they will remain, they will dissociate easily. So H plus concentration will increase. If H plus concentration will increase, then the pH will decrease. Okay, so that is your option answer for this question. Okay, so let me just clear. Yes, you can see here acid species which donates a proton and base is something which accepts a proton. HNO3 and NO3 minus are one pair, H3O plus and H2O is another pair. Now pH will decrease because NH4Cl being a strong salt and a weak base undergoes hydrolysis to give you acidic solution. Okay. Okay, let us see the next chapter, that is redox reaction, and let us solve some quick questions from here. Okay, so the first one is, what is a disproportionation reaction? Given example. So you know any reaction in which both like the same compound undergoes oxidation and reduction, that is called as disproportionation reaction. Okay, so you can have this example, H2O2 gives you H2O and O2. Now what, write the oxidation half of this reaction. So here if you can see, Fe is in +2 state, Fe is in +3 state, so oxidation number is increasing, so there will be oxidation. So here this part is your oxidation part of the reaction. Let us see this question. You have to balance the redox reaction. So I have, let me write the reaction here, MnO4 minus plus Br minus, okay, that gives me MnO2 plus BrO3 minus is here. Okay, so that means BrO3 minus, so this is +5, right? So now here to here, if I calculate the oxidation number, +7, here it is +4, so it is 3, here it is -1 to +5, right? So that is equal to 6. So I can just multiply this one with 2, right, to balance this one. So 2 MnO4 and 2 MnO2. Now if you see, oxygen here is on 8 and here it is 4 plus 3 7. So for adding one more oxygen, I will add H2O. Now to get this one, I have got 2H plus, so that I will add on this side. So now let us see the atoms, 2Mn is there, okay, then 1 bromine is there. Oxygen I have 8 and I have here 2 to the 4, 3, 7 plus 1, 8 oxygen. Here I have 2 hydrogen and 2 hydrogen. So now what is the charge here? Here +2 charge is there, then here I got -2 charge and here I got -1. So total charge is -1. Now here I have total charge is -1, so it is balanced. Okay. Next, okay, what is the oxidation number of chlorine? If you just calculate here x +1 and -6, you will get chlorine oxidation state is +5. Okay, now if you just want to separate the oxidation and reduction, here Fe to Fe +2, right, and here +1 to 0. So this is your oxidation reaction and this is your reduction reaction. You can write down it separately. Okay, next we'll go to the organic chemistry chapter. What is Woods reaction? Write with an example. So Woods reaction is those reactions where the haloalkanes react in presence of dry ether to give you alkanes, right? So you can write one example. You can take Rx with dry ether, so this will give you RR. Okay. Next you have these compounds question, write the complete structure. So CH3 double bond, so you just have to draw the bond line formula. Then identify the number of sigma and pi bond. So if you see, the structure is like this, right? CH triple bond C, then I have CH double bond CH, then CH3. Okay, so how many sigma bonds we have? 1 2 3 4 5 6 7 8 9 10. Okay, so I have 10 sigma bonds. And how many pi bonds we have? We have 3 pi bonds. Okay, identify the type of hybridization of each carbon. So if you have 2 sigma bonds, this is sp, 2 sigma bond, this is sp, 3 sigma bond, this is sp2, 3 sigma bond, this is sp2, and 3 sigma bond, this is sp3, 4 sigma bond, that is sp3. Next, write the bond line formula. You can just draw the bond line formula here. Mention whether the compound is saturated or unsaturated, because we have double and triple bond, so this compound is unsaturated. Okay, very simple question. Next, name the method by which the halogen present in the organic compound is estimated. 0.1 gram of an organic compound gives 0.08 gram of silver bromide. Calculate the percentage of bromine in the organic compound, atomic masses of given compound. Okay, okay. So first of all, we know this formula, right? So calculate the percentage of bromine. So if you know bromine is how much, in the formula for calculation of bromine is 8 by 188, okay, into we have to do the amount of silver bromide that is produced in the reaction, right? 0.08 divided with mass of the organic compound 0.1 into 100. Okay, so this is what mass of bromine. Okay, you can do the calculation and check the answer how much we are getting. Okay, next, what is inductive effect and which one of the following shows maximum hyperconjugation effect? So inductive effect is what? It is the pulling of electrons, right? It is the pulling of electrons by the more electronegative atom, pulling of sigma electrons by the more electronegative atom towards itself. Now, which one of the following shows the maximum number of hyperconjugation? So you have to see the number of alpha hydrogens here. So if this is the structure, here we have 3 alpha hydrogen. If this is the structure, here we have 6 alpha hydrogen, and here we do not have any alpha hydrogen, so number of alpha hydrogens is more here. So this one will show maximum number of what? Hyperconjugation structures. Okay, fine. Okay, just a minute. Yes. So yes, students, these were the most important questions. Okay, so I want you to focus on these questions, score it, learn these questions perfectly, and go for exams. Definitely you would be able to score very good marks. And if you have any doubt in any question, please comment down. I will definitely address to it. Thank you for watching, and see you soon in the next episode. Till then, please study hard. Your exams are very, very near. Okay, all the very best, students.